So what am I entering in this formula? Here's what I'm entering. I'm entering n as being 36 because it's 3 years times 12. So this is 36 as well as here. I'm entering the principal as 18,000. And I'm entering R, which is the annual interest rate, as a decimal as 0.046. I'm going to write it one more time so we can see it with those numbers in. So 18,000, 0.046 divided by 12, 1 plus 0.046 divided by 12, everything to power 36, everything divided by 1 plus 0.046 divided by 12, everything to power 36, and minus 1. This is nice and beautiful, but this is not going to be entered like this. We're not going to get anything if we enter it as you see it. So first of all, I have to have parentheses around the numerator. I also have to have another set of parentheses around the denominator. I will have to have parentheses around this portion as well. So again, not easy to enter in the graphing calculator. We have to be very careful. Okay, so I'm going to share my screen. Again, I would like to record this, although I haven't recorded with another class before, but I'd like to record it again here. And I have a problem. I may lose the first recording. I'm going to show you, but I'm going to record it at the end of the class after the previous recording is yeah, after the first. I'm not sure if I'm losing the first recording if I record again. Does anyone know?
I would assume you would lose the first recording.
It will.
I think it would just pause it, and then you don't have to restart all over again.
So you're saying that I will lose the first one?
It might be saved to your computer, but it's not stop the first recording. That's what I'm saying.
Okay. So I have this example in the previous class, so I will move that video. Okay, so be careful how you enter it. So 18,000, left parenthesis for the numerator, another left parenthesis for 0.046 divided by 12, close, open another one, 1 plus 0.046 divided by 12, close, caret 36, close again, not there. Here, divided by left parenthesis again, 1 plus 0.046 divided by 12, close, power 36, down, minus 1, close. Do not try to do it piece by piece. You're introducing a lot of error and you're not going to get the correct answer. It has to be entered in one step, like I did here. When I press enter, this will tell me how much I have to pay per month in order to return the money, with interest, of course, to the bank. So that's my page 3. So M, the monthly payment, is 536.25. The hundredth digit is 4, but the thousandth digit is 9. So 25, okay? And this is per month. If I want to find out how much I'm paying back, I'm going to multiply by 36 months. So if I multiply 536.25 multiplied by 36 months, I'm giving back a total of $19,305. And the loan is $18,000. So I'm basically paying the bank $1,305 for the loan. For the 3-year loan, I'm taking a loan of $18,000. I'm returning $536.25 per month. Total for 36 months, I'm paying back in 3 years $19,305, which makes the bank richer by $1,305. Any questions on these problems? Anyone? I hope I didn't lose anybody.
Can you go back to right next to 536.25?
Yes.
Yep. Is that an R? So you're saying the
Dollars. This is dollars.
no right before the equal sign.
It's M.
Oh, M. Okay.
No, that's okay. That's okay. You're gonna get used to. I'm so sorry. So this is M, the monthly payment per month. In other words,
Got it.
so how much we pay per month, the uppercase M, and this is in dollars, 536.25 per month. I also remember that I want you to keep up, of course, because I'll ask you questions, but these will all be posted, as you know, for your review. Okay.
Okay. So you have M equals 536.25 divided by
Per month.
per month. Got it. That's what I missed.
No worries. It's a lot of information. Every day we're going to have a lot. So $536.25 per month. So that raises a very important issue. Notice that I write the measurement unit every time, everywhere, all the time. So please remember, this is a requirement. I wrote 3 years, I multiplied by 12, and I said 36 months. I obtained an answer, so this is dollars per month. And this is the extra. And there's all dollars, okay? I forgot here. Okay? So please always get in the habit of writing the measurement unit.
You said if we put in a calculator separately, we would have way too much of an error.
Yes.
Yes. How big is the error?
I have no idea. It depends on how many digits you put everywhere.
Okay.
I have no idea.
So, assuming I wanted to, put it separately just out of force of habit.
No, you cannot. Please don't. Please don't. Please.
Okay.
I'm begging you, do not. That's why we're here. That's why we learn this, to make it as easy as possible. That's why we learn this function, not to do this by hand.
Okay.
Yes, please. Because that takes care of all the steps. If you make a mistake here and you make a mistake here, the whole thing collapses. It's very easy to make a mistake. Also, it's not very easy to put it in, so you have to be careful how you put it in, because if you don't put parentheses here, you may get away with it. But if you don't put parentheses around the numerator and parentheses around the denominator, you will not get away with it. In other words, the answer will be incorrect.
What I mean is, can you do what is that? 18,000 times the top, and then enter, and then divide it by the bottom. That's what I meant. I'm sorry if I didn't explain that right.
So you wanted to write 18,000 times all this.
Yeah, and then press enter, so we get my answer, and then divide that answer by the bottom.
It may work. It may work, but if you forget to put parentheses,
it's gonna throw everything else.
You're not gonna get the same thing.
Okay.
So be very careful.
So might as well just do it.
Yes, I understand, and I agree with your method completely. So you can multiply 18,000 by all this, and then divide by this. Press enter first, and then the calculator will do that. But if you omit parentheses here, you're not dividing by this amount. You are dividing by this and then subtracting 1.
Okay.
Which will not give you anything.
Okay.
Okay, I agree with the method. I understand now. Perfect. Other questions? Very good questions. Thank you. Anything else? Okay, I would like to continue. I'd like us to move on. And the next section is also a review. It's all about functions and models. And what I would like to discuss here for functions, so let me see, which page is that? Directly page 22. So let's look at a few graphs. By the vertical line test, is 48 a function? Do we remember the vertical line test?
No, it's not.
It's not a function because by the vertical line test, it crosses the graph in more than one point. Very good. What about 52? Is this a function?
Yes.
Yes, because by the vertical line test, any vertical line crosses the graph in only one point. What about 43?
Yes.
Yes, perfect. Okay. What I would like to discuss next is before later on we discuss domain and range. They should have been in this section together, but they are not. But that's okay. I'd like to discuss something like this concept. Okay, but I need to explain what this means. I can't just ask you, okay, let's calculate something. Okay. So when we determine the average rate of change of a function between 2 points, it's a mouthful, right? Average rate of change of a function between 2 points. What is this? Here's an example. I start in Baltimore and I want to go to New York. And let's say the distance is 200 miles. And you ask me, what was your average rate of change of distance with respect to time? You're basically asking me the average rate, average speed. You're asking me find the average rate of change of distance with respect to time. That's the average speed. What was your average speed between Baltimore and New York? And I'm going to say the distance was 200. It took me 6 hours. And that was my average rate of change of distance with respect to time. That was my average speed. Whatever that comes out to be. That's my, and it has to be in miles per hour, always measurement unit. So that's exactly what we're doing. If this is a function, and I have 2 points, this is 1 point, and this is another, this is Baltimore, and this is New York, and this point has coordinates x1 comma f of x1, and this is second one, x sub 2 comma f of x sub 2. How will I find the average rate of change of this function? It doesn't have to be distance, right? Any function between these 2 points. Exactly how I determined here. Same procedure. I at least imagine that I draw a line through these 2 points, and I find the slope of this line. How do I find the slope of this line? Anyone remembers how to find the slope of a line? And I'm going to call it secant line. A secant line crosses a function in at least 2 points. It can be more, but in 2 points, not 1, 2 or more. Can anyone refresh our memory on how to determine the slope of a line?
Are you looking for the slope formula?
Yes.
Y2 minus Y1 over X2 minus X1.
Excellent. Perfect. Very much. Thank you very much. But what is Y2, Y1? This is Y2. And this is Y1. So for the average rate of change, we will write f of x sub 2, Y2, minus f of x sub 1 over x sub 2 minus x sub 1. Exactly the same formula. And this is exactly how I determine this. How come? Yes, the distance. Y2 minus Y1, the distance was 200. And the time from 1 a.m., I'm sorry, 1 p.m. to 7 p.m. 7 p.m. minus 1 p.m. is 6 hours. Distance 200 minus 0, 200. Exactly the same procedure. So this is the average speed or the average rate of change. This is the formula. So this is something again for your notebook with all formulas. Okay, how is this related to what we are trying to find? Here it is. I'm going to graph the same function. I'm going to graph the same points, but this time I'm going to change the coordinates. I'm going to put something different here. I'm going to put for this point, I'm going to put the same, but x comma f of x. And for the second point, which is the second point, I'm going to tell you that the second point is very close here. Very, very close. But I'm going to zoom in because if it's this close, how do I show anything? I can't. So the second point is extremely close, but because I'm going to zoom in, it will appear far away. Since this is very close to this, it means that the x coordinate of this point is very close to this coordinate. So I'm going to say it's x plus a little bit. This is lowercase h. Because this point is very close. So if this is 1, this is 1.1. If this is 1, this could be 1.01. Very close. Of course, comma, f of that value. X, f of x. X sub 1, f of x sub 1. X plus h, f of x plus h. And I'm going to ask the same thing. It's the same procedure. This time, this point is very close. And because it's very close, I'm just going to add tiny bit to it. X plus a little bit. F of x, and f of x plus that little bit. This is what we are trying to do, and this is a huge part of this class. It's called the difference quotient. The difference quotient. Same formula, but for this scenario. So then the difference quotient, dq, difference quotient is, same thing, f of x plus h minus f of x over x plus h minus x. Same formula, same slope. F of x plus h minus f of x divided by x plus h and minus x. And yes, of course, these two simplify. This is what we are asked to determine now. F of x plus h minus f of x divided by h. Where does this come from? From the average rate of change. These 2 points are distinct. They're not very close. They're distinct. These two are distinct as well, but they're very close. How do I know? Because this is x plus a little bit. So h, a little bit. Tiny. because the points are very close. I zoomed in so I can discuss the situation. So if this is 5, this is f of 5. If this is 5.1, this is f of 5.1. Okay, make up any function. If anyone would like to make up a function, any quadratic function, quadratic. So we can determine the difference quotient. This is again something very, very important in this class. Can anyone give us a quadratic function, or we can use the function from the book? It's up to you.
Can we use one from the book?
Yeah. So you want to use, I'm just going to beef it up a little bit. So I'm going to say it is x squared minus 3x plus 5. So what is the question now? So let's try to understand the question, first of all. We're asked for this function, find and simplify the difference quotient. Find it and simplify it fully. So major keywords in math are factor and simplify. You're going to hear me say this all the time. Please factor and simplify if possible, anytime. Okay, so in order to find the difference quotient, which is this is the difference quotient. First, let's analyze these three pieces. No one can do anything to h. It's just tiny number. No one can do anything to f of x because I already have it. I just have to replace this piece by x squared minus 3x plus 5. This is the only piece I do not have. I have to calculate this first. Okay, so let's calculate it. Question first. For this function, if I ask you to find f of 0, what will you do?